This hearing will come to order. Without objection, the chairman is authorized to declare recess at any time. Before I deliver my opening remarks, I wanted to note that today the committee is meeting virtually. I want to announce a couple of reminders to the members about the conduct of this hearing. First, members should keep their video feed on as long as they are present in the hearing. Members are responsible for their own microphones. Please also keep your microphones muted unless you are speaking. Finally, if members have documents they wish to submit for the record, please email them to the committee clerk, whose email address was circulated prior to the hearing. I now recognize myself for an opening statement. Good afternoon, and thank you to all of our witnesses who are joining us virtually today to discuss the importance of sustainable buildings research. This is a critical component of fighting the climate crisis. In my state of New York, we have some of the most densely populated cities in the country. We also have some of the most aggressive climate goals in the world. Thanks to a broad coalition of social movements, New York State passed the Climate Leadership and Community Protection Act in 2019. Part of this law was the inspiration for President Biden's Justice 40 initiative, which will channel 40% of the federal government's climate investments into marginalized communities. Also in 2019, New York City passed a first-of-its-kind law to cut greenhouse gas emissions from buildings. Now, we need to come together as a nation and build on these victories at the federal level. When we think of reducing emissions, we often think of renewable power or electrifying our transportation sector. But another large source of emissions, especially in New York, is buildings. Currently, about 40% of our country's carbon dioxide emissions comes from the structures that we live, work, and sleep in, and that we depend on for life-sustaining care. This goes to the heart of why we need to address climate change, inequality, and racism together. As we have been discussing on this committee, when climate disasters strike, redline communities of color and low-income people are hit hardest. They're the first to lose power when the electricity grid is strained, as we saw in Texas, and these are the same communities that struggle with housing and utility costs. They face health risks from toxic materials in buildings, including in public housing that we have allowed to fall into a state of disrepair. In my district and around the country, the people who live in these buildings have been dying at higher rates from COVID, partly because of comorbidities caused by the fossil fuel economy. We need sustainable buildings now, and we need to rebuild our communities from the ground up. The Department of Energy invests millions of dollars every year in improving building technologies in a variety of ways. DOE, along with other federal science agencies, plays a role in making buildings more resilient to extreme weather. DOE also researches energy efficiency and increased electrification in buildings, with an emphasis on ensuring the equitable distribution of the effects of this clean energy research. Let's also think about how federal research can become more interdisciplinary. Social scientists, for example, have started exploring how green investments in neighborhoods can lead to gentrification. This process is not only unjust, but can undermine climate goals. Instead of cutting emissions for everyone, this can create a low-carbon economy for people with privilege while displacing communities of color and other low-income people out of dense, walkable neighborhoods. We need a combination of natural science, engineering, and social science to guide equitable and effective green investments for everyone. And research alone won't be enough. The other work that DOE must continue to focus on is how to get the results of this research into the hands of the communities that need it most. A week ago, I released a proposal to heal our K-12 school system from the impacts of climate change and the pandemic, and from decades of disinvestment. A huge part of this plan is focused on retrofitting public school buildings and removing toxic materials, beginning in the highest need districts. Schools can become living laboratories for the energy transition, putting students and young people at the center of the Green New Deal and launching STEM careers across the country. Big problems require big solutions, and that is exactly what we will be pursuing together on this committee. I am excited to chair the Energy Subcommittee this Congress, and to hold this first subcommittee hearing on such an important topic. Investing in building technologies means investing in a safe, healthy future for our country and for the entire world. I want to thank our excellent panel of witnesses assembled today, and I look forward to hearing your testimony. With that, I yield back. The chair now recognizes Mr. Weber for an opening statement.
Well, thank you, Mr. Chairman. Welcome to the committee. We're going to have a little fun. We're going to be a lighthearted committee. We're going to be very serious about our work, serious about what we do with energy and for our country. So I appreciate you being here, Chairman Bowman. And thank you to all. My thanks I want to add to all the witnesses for being with us here virtually this afternoon. I will tell you that today we're going to discuss building technology research and development needs. And while I'm excited to hear about the critical work being performed by the Department of Energy's Building Technologies Office, and quite frankly, all across DOE, I want us all to be mindful of the role that industry can and should play in this area, especially where there is a clear incentive and an ability to take up mature technologies. I say this as someone who knows the building industry firsthand. In the 1970s, I couldn't even spell air conditioning, or what we call AC in Texas. But by the mid-90s, I was actually running my own AC company. And I can tell you innovative material science, data analytics, and advanced sensors and controls, and private-public partnerships with these labs are exactly how we get the most bang for our taxpayers' buck when investing taxpayer dollars in this research. DOE partnerships with industry and academia enable the development of new technologies that can increase the energy efficiency of building envelopes, improve construction practices, and meet the demand for greater energy generation capacity. Today, we will hear from Dr. Jim Tour of Rice University in my home state of Texas, who will give us his perspective as one of those partners. As a professor of chemistry, along with material science and nanoengineering, Dr. Tour's research focuses on advanced building materials like, for example, lighter, stronger concrete that is a result of turning waste into a manufacturing additive called graphene. I look forward to hearing his testimony on how fundamental materials research can transform building technologies, and how, at the same time, how successful public-private partnerships have supported these innovations. Just like Dr. Tour's example of turning trash into treasure, we can support a future that protects our environment for the next generation and is affordable for all Americans. But we won't necessarily accomplish this by doing what we call in Texas, just throwing in the kitchen sink and billions of dollars at a broad, unspecified portfolio. Instead, we should make our clean technology affordable through significant investment in fundamental research paired with targeted and responsible investments in applied energy R&D. That is why this week I was proud to sign as one of the original co-sponsor of Ranking Member Lucas's Securing American Leadership in Science and Technology Act. This legislation supports a diverse, all of the above clean energy strategy and prioritizes critical research to establish U.S. leadership in industries of the future like advanced materials and manufacturing. This long-term strategy for investment in basic research and infrastructure is how we in Congress should support innovative building technologies. It creates a pipeline from lab to market and is the most direct and efficient path to a more sustainable future for both new and current buildings. Thanks to the witnesses. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Weber. The chair now recognizes the chairwoman of the full committee, Ms. Johnson, for an opening statement. If Ms. Johnson is not present at this time, the chair is going to move forward. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witnesses. Dr. Nora Esram is the Senior Director for Research of the American Council for an Energy Efficient Economy. Dr. Esram oversees ACEEE's research programs on buildings, transportation, industry, and behavior. Dr. Esram holds a PhD in architecture from the University of Illinois, Urbana-Champaign, and is a licensed architect. Dr. Roderick Jackson is the Laboratory Program Manager for Buildings Research at the National Renewable Energy Laboratory. His portfolio includes a broad range of research, development, and market implementation activities that aim to improve the energy efficiency of buildings, materials, and practices. He holds a bachelor's, master's, and PhD in mechanical engineering from the Georgia Institute of Technology. Dr. James Torr is a TT and W.F. Chao Professor of Chemistry, Professor of Computer Science, and Professor of Materials Science and Nanoengineering at Rice University. He received his bachelor's degree from Syracuse University and his PhD in chemistry from Purdue University. Ms. Jacqueline Patterson is the director of the NAACP Environmental and Climate Justice Program. She has worked as a researcher, program manager, coordinator, advocate, and activist working on women's rights, violence against women, HIV and AIDS, racial justice, economic justice, and environmental and climate justice. She received her master's degree in social work from the University of Maryland and a master's degree in public health from Johns Hopkins University. Last but certainly not least, Mr. Joseph Hagerman is a section head for buildings technology research at Oak Ridge National Laboratory. He leads the lab's research in building envelope materials and equipment, as well as in integrated building performance and multifunctional equipment integration. He holds a master's in civil engineering from the Fu Foundation School of Engineering and Applied Science at Columbia University and earned his bachelor's in architecture from Mississippi State University. Thank you all for joining us today. As our witnesses should know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you all have completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. We will start with Dr. Esram. Dr. Esram, please begin.
Thank you. Chairman Bowman, Ranking Member Weber, and members of the committee, thank you for inviting me to testify on the topic of building technologies research and development. I bring with me today my 20 years of knowledge and experience as an architect, an educator, a lab scientist, and now as research director at the American Council for an Energy Efficient Economy. Building efficient technologies are known to lower energy costs and create local jobs. But the biggest opportunities are still ahead. Improving efficiency of buildings has the potential to reduce U.S. greenhouse gas emissions by 20%. The industry needs help from the federal government and science community to develop integrated solutions and productive processes to upgrade existing buildings faster. Building retrofits also improve occupants' health, comfort, productivity, and community resilience. Today, many of our buildings aren't served as well. For instance, when COVID-19 hit, public health experts suggested increasing indoor ventilation and filtration to lower disease transmission risk. But many legacy building systems can't handle that. When offices were sitting empty during the lockdown, they still consume 40 to 100% of their usual energy. That's huge waste. When the power went out across much of Texas, many poorly insulated homes quickly dropped to near freezing temperature. Imagine if these houses could have been kept warm with a heating device as small as a hairdryer. That's not a dream, that's efficiency building technologies. Thanks to decades of federal investment in research, we have many technologies to make buildings efficient, healthier, and resilient for everyone. But we don't know yet how to expeditiously deliver these technologies to existing buildings. Improving construction productivity offers a path. If construction labor productivity were to catch up with the progress made by other sectors, we'll gain $1.6 trillion economic growth globally. A third of that is in the US. Many countries are moving on-site construction toward a manufacturing-inspired mass production platform. We lose our competitive edge if we don't take bold actions. Transforming the building industry would also provide an opportune time to reduce embodied carbon in building materials and products. I also believe a strong and creative workforce is key to success. We need to equip building contractors and specialized trades with knowledge and skills to adapt to new technologies. We need to educate and attract a new generation of innovators and entrepreneurs. Buildings of the future are machines that interact with the grid and transportation systems. Workforce development is a creative and interactive process. Therefore, we need federal R&D support to grow tomorrow's building leaders outside the classroom. I urge Congress and DOE to take bold actions to lay a solid foundation for a successful transformation of the building sector. First, spur modernized approaches to accelerate deep energy retrofits and create local jobs. Second, train and diversify our workforce and inspire a new generations of leaders. Third, drive enduring market transformation through integration of efficiency with health, resilience, and other societal goals. Last but not least, collaborate with local and state governments and community-based organizations to create proactive, replicable solutions for all. I truly believe that we are facing a paradigm shift. Together, we can both create and witness history. Thank you again for the opportunity to testify, and I look forward to your questions.
Thank you, Dr. Esram. Dr. Jackson, you are now recognized.
Thank you to the subcommittee for giving me this opportunity today to provide a testimony on a topic of critical national importance and deep personal passion. So my bio is included in the written testimony for reference, so I won't get into those details, but I wanted to provide a personal perspective of who I am and my passion. So my father, Louis C. Jackson, was one of 16 children, and out of 11 boys, they all built houses. So construction was a deep passion for my daddy, so much so that he first introduced it to me when I was only 3 years old. I think my first job was to go out on the job site and pick up all the straight nails. A little after finishing my undergraduate degree, he and I formed Nora Jackson Construction back in my hometown of Canton, Mississippi. However, my personal passion for science and engineering drew me back to Georgia Tech to complete my PhD, but the legacy my dad and his 10 brothers they left was never far from my heart. I've since been able to marry my love for science with family legacy, and that brings me here today. Unfortunately, my dad passed away on January 19, 2021, but the opportunity to provide a testimony on the future of the industry he loved so dearly is immensely fulfilling. So let's talk science. So because buildings consume about 3/4 of our current electricity demand, it can be a large part of the sustainable energy solution. By leveraging energy efficiency, greater connectivity, advanced data science and analytics, along with next generation materials, sensors, and controls, buildings can be designed to synergistically interact in real time with the electric grid to provide demand flexibility, all while not compromising comfort, health, or productivity. DOE is leading the charge in this new vision for the pivotal role that buildings can play, and has appropriately titled this initiative Grid Interactive Efficient Buildings. In my written testimony, I highlighted how modeling, sensors, and controls enable this future of grid interactive efficient buildings by providing a platform to understand, plan, and optimize the performance of buildings in varying scenarios. I provided Redstock as an example of an idea first cultivated by laboratory-directed R&D funds, then developed by DOE funding and support, and is now currently being used by multiple research activities as well as private sector use cases. In my written testimony, I also highlighted the need for thermal energy storage because thermal end uses like space conditioning, water heating, and refrigeration represent roughly half of our building energy demand. Thermal energy could be stored as a complement as well as an alternative to battery energy storage to balance supply and demand. Now, I'm particularly excited about a publication, an in-real publication in this month's Nature Energy Journal. It presented an analogous adaptation of the energy power trade-off curve that has been foundational in the design and advancement of battery systems. This and others are really just some of the examples or opportunities that we can use to further accelerate the deployment of thermal storage as a viable energy storage solution. So as we continue to advance the science and engineering of individual grid interactive efficient buildings, there are actually new possibilities that emerge that aggregate a collection of buildings with other local distributed energy resources into connected communities. So not only can we then seek optimized solutions where the total is indeed greater than the sum of the individual parts, we can also enable innovation at the intersection of these diverse and distinct technology domains. However, unfortunately, according to a recent McKinsey study, labor productivity in the U.S. has remained stagnant over the last 80 years, approximately marking the time when the first Jacksons began to master the carpentry trade. So this reality not only hinders U.S. competitiveness, it limits the transition to a sustainable energy future with affordable building construction and retrofit costs. But DOE's Advanced Building Construction Initiative targets this opportunity with a vision to integrate higher levels of energy efficiency into new construction and retrofits. So as we transition to a sustainable energy future, we have to ensure the benefits as well as the costs are more equitably distributed. However, examples of centering equity in energy technology, energy innovation, and energy transition are most often focused on the deployment phase of the research, development, demonstration, and deployment spectrum. However, while this is important and essential, deployment is the final stage of that technology spectrum I just described. And so as a result, in many cases, it actually may be more difficult to equitably deploy technology that was developed without regard to equity. In other words, this approach could be akin to attempting to force a square peg into a round hole. So as an alternative, the R&D community, the community to which I belong, should take the additional step of centering equity into the early stages of the technology development pipeline. And then also due to historical underinvestments, the solutions faced in low-income communities are actually different and distinctly more difficult to overcome in many cases. Hence the need for science, engineering, and innovation are even more pressing. So in summary, thank you for this opportunity. And to meet our nation's goal and continue our American leadership in energy innovation, we should continue to prioritize R&D investments in building technologies. I look forward to any other questions you may have. Thank you.
Thank you so much, Dr. Jackson. Dr. Tor, you are now recognized.
Thank you, Mr. Chairman. I'm a professor of chemistry, material science, and nanoengineering at Rice University and part of the Welch Institute for Advanced Materials. I have 730 research publications, 234 of those on the topic of graphene. I have over 50 U.S. patents plus 90 international patents on graphene. In the past 6 years alone, my academic research has led to the formation of 14 companies, 8 of those in nanomaterials, and 2 of them now public companies. On March 15, 2017, I gave testimony before the Energy and Commerce's Subcommittee on Digital Commerce and Consumer Protection on the topic of graphene and attaining U.S. preeminence. 4 years later, I'm here to report that the future has arrived. What is graphene? Think of it as carbon chicken wire. That's what it looks like. Chicken wire in its atomic arrangement, but on the 1 atom thick scale. Graphene is a non-toxic, naturally occurring carbon material, and its agglomerates are the natural mineral graphite. It is very slow to enter the carbon dioxide cycle, and hence it can be considered a terminal carbon sink with near zero contribution to greenhouse gas emissions. Graphene is a revolutionary material for building construction, but until recently, affordability and access to sufficient quantities made it only a dream for those applications. In 2018, a graduate student in my laboratory, Due Long, working under funding from the Air Force Office of Scientific Research, discovered a process that we call flash graphene. We immediately filed patents to protect the technology, and companies were formed 1 year later, Universal Matter Inc. and Universal Matter Limited. The process can take any carbon material, and convert it into graphene in less than 1 second, using only electricity, no water, no solvents, no additives other than carbon itself. This new graphene manufacturing process will lower the cost by a factor of 10, therefore making it economically viable for use in building materials. The majority of waste products generated by human beings are carbon-based. If it's not rocks or water, it's probably carbon. We can take coal, petroleum coke, unsorted plastic waste, discarded food, mixed household waste, any other carbon source, and convert it into graphene. Our production rate is doubling every 9 weeks, thereby projecting to hundreds of tons per day scale within 3 years. With grants from the Department of Energy and Department of Defense and collaborations with the Army Corps of Engineers, ERDIC, Argonne National Laboratory, and several large automotive, concrete, asphalt, and wood manufacturers, we're developing graphene for concrete, asphalt, aluminum, plastics, polymer foams, lubricants, rubber, wood, fabric, and paint composites. By adding just 0.1 weight percent, that's 0.1 weight percent to cement, we get a 35% enhancement in compressive strength. It means we could use 1/3 less cement for construction. And since cement and concrete constitute 8% of all worldwide carbon dioxide emissions, that could translate into a remarkable diminution of emissions. Concrete alone is a $30 billion new market opportunity for graphene. 0.5 weight percent addition of graphene to asphalt will triple the life of the road. 0.05 weight percent of graphene to carbon fiber composites will lower the weight of an aircraft by 20%, translating into enormous fuel and carbon dioxide reductions, all made possible by this U.S. invention. Through Rice University's Carbon Hub, we're developing methods to convert natural gas into hydrogen and graphene with near zero carbon dioxide emissions. That's clean hydrogen fuel from natural gas. The next step is to develop entirely new classes of graphene composites that can substitute for the energy-intensive 2,500-year-old materials that we use today, like concrete and steel, while providing a non-toxic carbon sink for most human waste products. The takeaway from my testimony is this. First, continue to foster basic support of basic and applied research directed toward advancement and deployment of new materials. A few years ago, graphene was only viewed as appropriate for ultra-high-end aerospace and device applications, but not anymore. The bipartisan Endless Frontier Act could embody an interesting approach to achieve the requisite research and translational goals. Second, it remains challenging to go from the lab bench to the build site with market profitability. Congress has immense power and influence over tax policy and administrative and regulatory burdens that can make or break our startup companies. Third and finally, streamlining the green card process for scientists and engineers that have received their PhDs in the U.S. so that people like Dewey Long, the Vietnamese graduate student that discovered the flash graphene process in my laboratory, can stay to develop their discoveries in our nation's companies. We just need to do it right, safeguarding U.S. intellectual property through background checks and security oversight. Thank you.
Thank you, Dr. Tor. Ms. Patterson, you are now recognized.
Thank you so much. It's an honor to be here with you all, and I appreciate having the opportunity to share these brief remarks. So the NAACP, when we first started doing this work, people were surprised that we were working on energy, much less the sustainable building sector. However, as one considers the extreme disparities in quality, safety, and health of the places where African American communities especially live, learn, work, play, and worship, for us, historic social, political, and economic disenfranchisement has been detrimental to generational well-being. In 1861 and 1862, the United States government passed the Morrill and Homestead Acts, which were intended to give land grants to white Americans for colleges and those seeking land to farm. These acts were also accompanied by offers of subsidies to facilitate the acquisition and use of the land. As slavery was not abolished in the United States until 1865, many enslaved and freed African Americans were unable to benefit from these acts. And a lack of legal services meant that African Americans who managed to acquire land couldn't even write legally binding wills that would facilitate legalized inheritance of property. This is all tied to the fact that overall economic insecurity has resulted in extreme income and wealth differentials that persist over centuries. Even now, at $171,000, the net worth of a typical white American family is nearly 10 times greater than that of a Black American family at $17,150. And for Black American single women-headed households, the average family net worth is nearly $5. At 44%, African Americans are least likely to be homeowners versus 75% of white Americans, and overall 65% for the nation. Historic and modern day redlining practices impact everything from whether we own homes, where we own homes, and the quality of the homes and other resources to which we have access. Also impacted is the quality of the infrastructure in our community, such as levees that protect our homes and property values that finance our schools. This also affects the quality of the buildings in which our schools are housed. Subpar quality of the buildings and structures in our communities means that we are inundated by energy burden, which challenges our finances, indoor air pollution, which sickens our family, and poor housing stock, which renders us vulnerable to disaster impacts. African Americans have the highest energy burden, which means that the amount of income that goes towards energy in the buildings we occupy is the highest of any other racial and ethnic group. African Americans are also more likely to have our energy shut off for non-payment, too often with fatal impacts as we pay the price of poverty and racism with our very lives. When a candle or a space heater or carbon monoxide has taken the lives of too many seeking to heat or light our homes, when our finances can't meet the demands of our bills. Yet we're more likely to suffer from the pollution being emitted from energy production, as we are more likely to live near coal-fired power plants, oil and gas refineries, waste-to-energy incinerators, etc. And we pay the price with our health. We are more likely to bear the impacts of climate change that results from emissions from buildings. We also know that energy improvements, whether it's weatherization, retrofits, clean energy like solar, are tied to home ownership and credit ratings, which are compromised by the historic and current factors I've already described. COVID-19 means that we're in buildings more due to remote working and due to the need for isolation, which means we are using more energy and also are more exposed to indoor air pollution. With 2020 being the hottest year on record as part of the progression of increasingly hotter years, as well as greater weather extremes, our ability to cool and heat our homes reliably and affordably becomes increasingly more critical. Yet communities and populations most impacted by these disparities are underrepresented in the building sectors and professions, including those working on building standards in terms of organizations, architects, and beyond. For example, just 0.03% of certified architects are Black women, while again, $5 is the average wealth of a single Black woman-led household, thereby arguably rendering us as Black women as the number one critical stakeholder in the future of buildings. Key steps to right the historic and present day wrongs include in campaign finance reform so that moneyed interests don't have their thumb on the scales of the change we need to have in advancing energy justice for all. Dismantling the weapons of mass destruction, including the formulas that tie property values with quality of infrastructure and services at the local level. Increasing investments in BIPOC, Black, Indigenous, and people of color, education and leadership in STEM. Increasing resources for job and business opportunities for BIPOC communities, and shifting wealth to community-led endeavors to develop sustainable, affordable, safe, and healthy infrastructure, including buildings. In 2018, the NAACP launched the Center.
Time's expired.
Oh, thank you. Sorry.
No worry. We'll come back to you when we get to questions. Thank you so much.
Sure.
Mr. Hagerman, you are now.
Thank you, Chairman Bowman, Ranking Member Weber, and distinguished members of the subcommittee. Thank you for the opportunity to virtually appear before you today. My name is Joe Hagerman. I lead the Building Technologies Research Section at the U.S. Department of Energy's Oak Ridge National Lab in Oak Ridge, Tennessee. I'm a building technologies researcher by education and training. I'm not going to take our time today to discuss how much energy is consumed in buildings. We all pay energy bills at the end of the month. In fact, last year, buildings used 74% of all the electricity in the nation at a cost of over $332 billion. I think we can all agree that's a big bill. I want to focus today on the impact that Oak Ridge has made with the support of DOE Building Technologies Office. It is our thesis that when a nation's buildings are cleaner and more efficient, and the effect can be profound, improving comfort, safety, and productivity. And it will take American labor and American jobs to realize these benefits. So what's Oak Ridge doing? Staff at the lab are accelerating clean energy innovation throughout a building's ecosystem. Our nation's fastest supercomputer at Oak Ridge speeds modeling and simulations to analyze the potential for retrofits down to the neighborhood level for every building in America. Our nanomaterial science leads to new building materials with extraordinary insulation and self-healing properties. And our engineering expertise continues to drive breakthroughs for new energy-efficient equipment like cold climate heat pumps, climate-friendly refrigerants, and advanced next-generation appliances. A lot of this sounds like science fiction, but it's not. It's science fact. And that's the currency of the lab, transformational science. A cornerstone for our research is, of course, our facilities, particularly the Building Technologies Research and Integration Center, or BTRIC. BTRIC is DOE's only user facility dedicated to accelerating breakthroughs for clean, energy-efficient buildings. But the largest contributor to our work is our partnerships. We partner with industries, universities, and communities, and we make good partners because success to my staff is clear, make positive, practical impact. Let me share with you about working at the lab. The sheer volumes of connections, interactions, and collaborations are what make Oak Ridge a special place to work. We foster great science because we invest in great diverse people, expertise, and skills. And equally important, we have clear goals. Our first goal is that Oak Ridge will continue to lead the building energy efficiency research for the nation. One example is how Viral Patel and his team at Oak Ridge developed piezoelectric drying science that mechanically shakes and vibrates fabric at a high frequency to remove moisture. They demonstrated a faster drying time with 5 times less energy that will one day reshape conventional residential dryers. To me, that's transformative. But let's transform it again here today by recognizing that these innovations can also provide a solution to the hard to decarbonize industrial sector. This is another important thesis to the lab's research and science. Our advancements can apply to other processes, and it's my hope that American companies engage with us to decarbonize all sectors. Our second goal, Oak Ridge will continue to pioneer connected smart communities for grid resilience, benefiting consumers and the grid equally. Group leader Heather Berry worked with Southern Company, Alabama Power, and Georgia Power to provide and prove that homes and businesses can provide essential stability to the grid. Heather and her team demonstrated a more than 30% decrease in overall energy consumption and an approximately 35% lower demand during peak winter, all with no impacts to comfort. More importantly, residents engage with their buildings and controls in no different way than normal. And that's Heather's thesis. Control science can be done behind the scenes. And with Oak Ridge's deep bench in cybersecurity, we can guard the associated data and control actions. Goal number 3, Oak Ridge will help lead the nation in meeting our decarbonization goals. Another group leader, Kashif Nawaz, is developing direct air carbon capture solutions with building equipment technologies. Looking forward, Kashif hopes to develop concepts and methods for net negative carbon buildings, where equipment can efficiently heat, cool, dehumidify the air while capturing CO2, all possible by relying on transformative science, not science fiction. In closing, Oak Ridge is a foundational partner that can accelerate the clean energy transition across the nation to all communities. And the challenges ahead the nation are great. I believe they are bigger than one person, one team, or one lab alone. It's going to take all of us, not some of us, to achieve our goals. But from great challenges, great opportunities emerge. Opportunities for equities, collaboration, and allies across the sciences. And opportunities to create good paying American jobs while we're at it. I'm proud to work for my staff every day and honored to work at Oak Ridge National Laboratory. Thank you.
Thank you, Mr. Hagerman. At this point, we will begin our first round of questions. The chairman recognizes himself for 5 minutes. Dr. Esram, thank you for your testimony. I appreciated your emphasis on the need to align carbon reduction with other social goals such as health and equity. I want to zero in on the health piece. We know that redline communities and poor people in this country face multiple health threats from buildings. Our public school and public housing infrastructure, for example, has major issues with mold, asbestos, and other toxins. What do we know about the health benefits of deep energy retrofits at this point, and what do we still have to learn? Can you paint a picture for us of how life could be better in a highly efficient, zero carbon home or workplace?
Well, thank you for the question, Chairman Bowman. What we know, decades of scientific research have proven the impact of a building environment on human circadian rhythm, immune system, cognitive function, and tacit performance. There are plenty of literature. But what we don't know is how to fully integrate this non-energy benefits with technology and strategy development that speaks to the consumers and the investors. And there are no standard methods to quantify and monetize these benefits in a trustworthy way for consumers. A quick example is when we buy organic food, we trust USDA organic stamps. There is a standard way to measure these non-energy benefits for organic food, the procedure, but we don't have those for buildings, for healthy buildings. That's my answer in a simple way. Thank you.
Thank you. Thank you very much. Ms. Patterson, thank you for being with us today. Can you speak more to the challenges involved in bringing sustainable building technologies to redline and low-income communities? I'm wondering what the CESBS program has learned about what the main barriers are and what we need to do to surmount those barriers. How can we scale up weatherization, energy efficiency, and electrification efforts in low-income and affordable housing, for example? What do you see as some of the research and policy needs here?
Thank you so much. So that's a lot of questions in one question. But so first, definitely some of the barriers are really just lack of investment in these communities, both not only in terms of homes, but also in terms of various structures and communities. And so whether we have the challenge I spoke of before with housing in terms of the historic challenges that have resulted in people in a disproportionate home ownership, and so much in terms of these kind of weatherization, retrofitting, clean energy, all of that is tied to home ownerships and being able to tie financing mechanisms to equity in one's home. And so that's definitely a barrier. In terms of ways that we can shift this is everything from making sure that there are economic opportunities to bring up the economic well-being of people so that they can make those investments and be homeowners themselves. But then also shifting, and so that's from an individual standpoint, but also shifting wealth to communities that have been underinvested in historically over time, shifting away from this notion of all of the what's available in terms of public finance being through property values, which we know just kind of continues to have the same communities not having the types of resources that are needed, and really thinking about new and innovative economic ways of lifting all boats truly, because we know that there are attempts through whether it's the opportunity zones or other types of mechanisms, but that have not necessarily been successful in actually lifting the well-being and the economic status and what's available in terms of finance for those communities. So we're actually advancing this transformational climate finance initiative to significantly invest in these communities and making sure that whether it's social impact investing or municipal bonds or other finance mechanisms, that they're being brought into communities in ways that aren't extractive or that actually put communities in the driver's seat so solutions actually work for them. And the Centering Equity in the Sustainable Building Sector initiative is a multi-sector initiative that pushes policies. That's everything from renewable portfolio standards to making sure that building codes are also tied to the economic engine to be able to ensure that people can be up to the standards that we're putting forward in building codes. So I don't know how much longer I have for a response, but I'll pause there because I know there's the whole rest of the time. Thank you.
That was perfect. Thank you so much. I now recognize Mr. Weber for 5 minutes.
Thank you, Mr. Chairman. I want to go to you, Dr. Tour. I want to make sure that what I think I heard. Are you with us, Dr. Tour?
I am.
Okay, good. You've got 730 publications. 230 of those were on graphene. And there was how many patents and how many companies formed as a result?
I have over 150 patent families, but 50 US on graphene and 90 international on graphene. Started 14 companies, 8 of those in nanomaterials.
Thank you for that. You said a decade ago, your program was supported by 90% by federal funds and then 10% by industry, and that was normal for many research groups. Then, due to a number of factors, you started appealing to industry and showing them how your fundamental research in nanoscience could address some of their technical needs. And boy, the numbers you just reiterated for us, if they don't prove that you were successful, I don't know what does. Yeah. This might surprise some people who think industry only wants applied research. So, Dr. Tudor, can you talk more about basic research, how it can deliver applications for industry, and specifically in the building technology sector, please?
Right. So thank you for that, Representative Weber. So what happens is I do basic research. I'm a scientist primarily, but the transition is something that we need to look for. How do I transition this into something that can be applied and utilized? And when we make discoveries, right away we need to be thinking, how can I apply this? And if we just publish a paper and just think somebody else will apply it, it just doesn't work. We need to carry that banner several more steps forward to show them how it might work. I don't have to bring it all the way to the building, but I have to bring it to a point where some company is really interested. So for many years, we would license our technology to big companies, and for one reason or another, it would stall in those big companies. So about 6 years ago, I made a categorical decision. We are going to start our own companies. And we're going to start our own companies and build upon those, because then we can control the technology and push it forward. And success breeds success. After we were successful with 1 or 2, then investors started coming and wanting to fund more and more. And part of that is, I say, you've got to continue to fund some of the basic work in my laboratory that will broaden the applications of these, and that then spawns new companies. So that's basically how we've done it.
Well, and that's a great segue, because when you talk about broadening it and spawning new companies, as you know, as a Texan, Houston is an active hub for oil and gas industry, and also the aerospace industry. And so these large industries have become interested in your work. And can you explain that why many of the quote building technologies in quote research projects have applicability actually to more than just the skyscraper construction business? What other abilities does it have?
Well, it has to do with roads as well as concrete for building, with paints, for wood composites. Everything is about lightweighting and using less materials. And when we use less materials, there's less carbon dioxide emissions, less energy put into them. And the processes that we've come up with, so for example, just plastic, just high density polyethylene is $2,000 a ton. We put in $30 a ton to convert waste plastic into graphene that can strengthen a huge amount of plastic with that. So these innovations have great implications for the energy industry and for lowering carbon emissions.
Sure, you betcha. Well, I'm just about out of time, so I will go ahead and yield back, Mr. Chairman. Thank you for your indulgence.
Mr. Caston is next.
Thank you so much. Always a pleasure on this panel, Mr. Chairman, and to our witnesses. This is a hugely timely hearing, not least because as we sail into thinking about infrastructure bills, we have some real opportunities, I think, to modernize our federal building stock, public housing, federal buildings, the whole scope of that. And it's going to be real important to understand, as we are prudent stewards of taxpayer capital, where the biggest bang for the buck is. So I want to start, Dr. Esram, I wonder, in the work you've done or your colleagues have done at ACEEE, as you're looking at building efficiency technologies, not the ones of the future, but the ones we can deploy today, what kind of simple payback can owners realize on these technologies? And if you had to pick sort of your top 3 absolute no-brainers that every building owner should do, what would they be?
That's not very easy to answer question. I would pick lighting and water heater, and probably some HVAC system, depending the home location, the building types. Yes, at ACEE we have done a lot of research. For most of building technologies, they pay for themselves. However, they may not pay fast enough to speak to the consumer's needs. There are additional benefits, as we discussed, the health, resilience, and the productivity. They haven't been really translated in a way that the consumer will value more of energy efficiency. If we have a way to quantify, monetize those, I think we can do retrofit much faster than we're doing now.
Okay, well, would that be a good area for further research then, to try to figure out how to monetize and understand those benefits?
Yes. Definitely. We have a lot of pieces of technology. We don't know how to build efficient, affordable, healthy, resilience building at the same time. They haven't been put together yet. Okay.
Well, a part of the reason that I started by asking about proven technologies is that a number of years ago, I had the pleasure of touring the Bullitt Center in Seattle, Washington, that my friend Dennis Hayes has been responsible for. Many of folks on this committee know Dennis as one of the co-founders of Earth Day. That building uses about 10,000 BTUs per square foot in a city that averages 90,000. So almost a tenth of the energy use with no compromise on it's a beautiful building. It's a wonderfully comfortable place to work. And they've done it with some low-tech stuff like natural lighting, with some high-tech stuff like continuous commissioning, and then really interestingly with some regulatory reforms that they actually had to work to get the local utility to pay them for the benefit they provided the utility for reducing peak energy demand in the city of Seattle. And that building was commissioned in 2013. There's no reason that technology couldn't be widely deployed other than perhaps people having access to capital and what those returns are. Can you tell us a little bit about the split incentive problem in buildings? Are you familiar with that term?
Yeah, of course. The split incentive, meaning if the landlord is paying for the retrofits, and then saving will be from the tenants because they are getting the saving on their utility bills.
So when you say that the analysis of some of the benefits is some of it's and I'm going to misquote you here, but some of them have a good payback, some of them don't. How much would that move if we solved the split incentive? So if we took a holistic approach, how many of these problems or the challenges you described would go away if we said, what is the total societal savings that would come from these investments? If we frame it that way, does it change your answer at all?
Yeah, absolutely. In the commercial real estate, there's like a 300 rules that on average you pay $3 per square foot for utility, $30 for rent, and $300 for your personnel's, your salaries. So if we're able to quantify all of them, energy benefits and pick it a package, and the investors, the building owners, the business owners, the tenants all have more incentives to work together to upgrade the buildings.
Well, thank you. And I see I'm about out of time, but perhaps we can follow up afterwards, because I think, again, as we think about making significant investments in our federal building stock, we've got a real incentive to save a lot of money for future generations. But as we think about how much money we're willing to spend and how to finance that, it's going to be important that we've quantified those savings as much as we can, and would welcome the opportunity to work with you and your colleagues to quantify that as we move forward. Thank you, and I yield back.
Ranking Member Lucas is next.
Thank you, Mr. Chairman. I want to thank you and the ranking member. This is a fascinating hearing and some really impressive witnesses today. With that, Dr. Tour, I'd like to turn to you and note that the Securing American Leadership in Science and Technology Act, SALSTA as a lot of us like to refer to it, creates a long-term strategy for investment in basic research and infrastructure to ensure American competitiveness in industries of the future. So with that, I turn to you. In your testimony, you noted that you or your companies have received grants from both the Department of Energy and the Department of Defense, and you've also collaborated with the Army Corps of Engineers. Having worked with different agencies, do you think a more coherent government-wide strategy on federal science and research efforts could assist federal agencies and the national laboratories in being a more effective partner to researchers?
Yes, absolutely. Anything that can be done to assist these interactions where we can work across, because the national labs have tremendous facilities that we at universities would love to be able to access. And working with the national labs has been terrific. I mean, we have representatives here today from Oak Ridge. We've published papers just recently with Oak Ridge, and we're doing more. And so to facilitate this, and then it's not just, then it goes from me to then the companies. The companies are able to work. And so we have both me at Rice University and the companies working with the Army Corps of Engineers. The company is doing much bigger projects. We're doing the nano-sized projects. So they're doing the macroscopic projects, but all working toward the same direction. So whatever Congress could do to streamline that would be terrific.
And how do you think such a strategy would impact international competitiveness in next generation technologies like building efficiency?
So one of the things that we have done in the past, because we didn't have access in the university to certain equipment, is we've established collaborations with overseas universities. And that's a shame. I mean, if we could keep it all here in the United States, that would be much better. And this has to do with the nanomaterials that are going to go into making building materials with a lot less footprint of energy. Like I said, concrete and cement, 8% of all CO2 emissions. If we can lower that, it is tremendous. And then the jobs, then it all affects right here. So it would be very good if we could streamline that and have to be less dependent on the excellent access to equipment, particularly in Asia.
Dr. Tour, our legislation I mentioned, SALSTA, also aims to expand our American STEM workforce pipeline and its investment in infrastructure needed to maintain domestic research facilities. So I'd ask you the following. What role does infrastructure, and by that I mean world-class laboratories, top-notch instruments, collaborative user facilities, have in attracting and keeping researchers here in the United States?
This is a very big deal. We have a brain drain going on right now because students are going back to their home countries rather than becoming professors in the U.S., which they have traditionally done, because of the lack of equipment and the lack of deep support from government agencies toward academic research. And they are going home because the packages they can get are much better. I've testified to Congress before on this same issue, that the brain drain that is currently happening in the United States is frightening. Many of these people would have stayed in the U.S. had the packages been here, had the equipment been here. So if we want to keep the first-class people here, we've got to have the infrastructure to maintain this.
And let me conclude by saying, Ms. Patterson, I very much appreciate your comments about the Moral Act of 1862. Hopefully, with time and generational societal change, we're overcoming those deficiencies. I'm very proud of the efforts made by Congress in 1890 to create the 1890 land-grant universities and the 1994s. At some point, and this is not the right venue, we should discuss how we address the proper funding of the 1890s. I have one of those in my district, Langston University, an outstanding facility, but making sure the necessary resources are there so that they can be fully utilized by people. With that, I yield back the balance of my time, Mr. Chairman.
Ms. Stevens is next.
Okay, great. Well, thank you all so much, and thanks to our chairman, and congratulations to him on his first hearing on a critical topic with some great witnesses. So our energy efficiency sector employs, just shy of 2.5 million people, according to the latest data that we have from 2019, and it's projected to grow at about 3.4% year over year, and that's according to the National Association of State Energy Officials and our Energy Futures Initiative. Yet 91% of construction employers in energy efficiency reported difficulty in hiring experienced trained workers. And we certainly hear from our construction and building trade stakeholders here in Michigan about our critical workforce shortage, which has been obviously exacerbated by COVID-19. and energy efficiency in buildings, as we've been talking about, has an enormous potential to be a job creator. And we want to have equity, we want to have inclusion, we want to target the needs, as our chairman was discussing. So, Mr. Hagerman, you discussed the need for workforce development and training in the energy efficiency sector. You've touched on that. Can we shed some light on the role that the federal government can maintain to help fill this gap? And could you also comment on programs at Oak Ridge National Lab that are working to address this need?
Absolutely. So, first, thank you for that wonderful question. And as I said in my both my written and my oral testimony, American jobs are so critical as we start to decarbonize all the sectors and we actually achieve the energy efficiency savings for the nation, particularly because these are jobs that are should be un-outsourceable, right? We need real people to go in buildings and make them more efficient. So let me first speak to what Oak Ridge is doing. And of course, I think we need to do more. We always need to do more to train the available workforce that are actually going to make good on the retrofits and all the other activities that American companies want to pursue. But we do three main things. One, we have the Oak Ridge Institute, which is a collaboration with University of Tennessee, where we're trying to grow the talent population and pool pipeline to actually train and educate the workforce of the future. And in one example, a colleague of mine works in the power electronics space. That is a space where I think that we need to spend a little bit more time and focus on actually making sure that Americans lead the intellectual pursuits in power electronics and advanced power electronics. It was a little concerning in the renewable space. We saw Huawei as the number one seller of solar inverters at one point in time, right?
Yeah,
so
we need this to be American jobs. No, and Ms. Patterson, thank you so much for your testimony. I wanted to give you back some of your time because I know 5 minutes goes quick, but you cite the lack of representation in certain energy efficiency fields, specifically that only 0.3% of architects are Black women. So let's talk about this a little bit more. What are some ways, and I've been working on this in my career before I got to Congress, very focused on this now, but what are ways in which we can target and train workers, particularly in communities of color, in an appropriate and significant way?
Thank you so much for that question. Yeah, so we have been working with Department of Energy specifically, and through the Solar in Your Community initiative, and also through their Solar Energy Technology Office around how do we start to deploy both kind of the skills and the resources to support kind of skills building as well as providing resources for entrepreneurs and vendors so they can be competitive in this market. So so everything from policy making, like local hire provisions and disadvantaged business enterprise provisions that are tied directly to these contracts, I think is critical. So that and then also ways that we can look at the investment in, I think as we talked before, in terms of the HBCUs and other educational institutions to ensure that we have a pipeline, the good kind of pipeline, in terms of pathways for folks to enter into these professions are critical as well, and really working closely with those institutions to help to build. And then also the skills training in terms of vocational training that's not necessarily through a university, but those making pathways, like we're starting a Solar Vets initiative to help to train up vets, just that's tied to the Solar Vets resources that are available that we'd love to see. I think they've cut back on the funding. We'd love to see that reignited and fully funded in terms of the Solar Vets initiative, as well as really some funding that would target women. We did a project that was doing
just finish up your last thought. Sorry about that.
Yeah, no, that's okay. So working with groups like Grid Alternatives and Sunrun and others that are specifically trying to train women and making sure that we have funding in that. So I'll stop there. Thank you.
Thanks. I yield back, Mr. Chair. Thank you.
Mr. Baird is next if he's available.
I am.
You may proceed.
Thank you, sir. I really appreciate your having this hearing, Mr. Chairman and Ranking Member Weber. And I see our Ranking Member Lucas is on here too, and he's always got an interesting perspective. But the thing that I was very interested in, Dr. Tour, I'm going to start with you because I found this carbon sink and the materials you mentioned kind of fascinating. And, we have a tremendous capability at DOE with the computer capacity we have to be able to advance this kind of technology. So I hope we can see a strong future partnership between the industry and our national labs and all this kind of research. But I would just like for you to elaborate on, using the material to make cement, airplanes, building materials, and how we get that to our rural communities and some of our more remote situations. So that's the question.
Yeah. So thank you, Representative Baird. This is a real material that is transforming right now. So like I said, our production rate is doubling every 9 weeks. So a single factory within 3 years will be able to produce hundreds of tons of this per day in about 3 years. And that's the projection rate. The collaborations right now are happening with companies that are testing these in concrete and asphalt. And one of those entities is the Army Corps of Engineers, ERDEC in Mississippi, because they have the capability to do this. And then there's agreements with companies. We're working with big auto manufacturers taking their waste plastic because they're responsible now, at least overseas. The American companies that sell overseas are responsible for their plastic in the EU now from every vehicle. And it's almost 200 kilograms of plastic in a car. We've converted that into graphene. We've given it back to them. They put it into new plastic that goes into cars. So it's really a wonderful cycle here. And the energy savings are real material. This is real material going into then construction, concrete, wood composites with wood manufacturing. So this is really beginning to transform this. And this is one of the things that's been permitted by keeping this in a small company where I can help to control this and say, no, we got to get these into these products, as well as small companies contacting me that want to deploy this. I say, okay, we're not in the big scale deploying right now, but that's going to come within a few years. And we mark down their names and we want to see this deployed.
Fantastic. I find that extremely interesting, and then with the ag background, some of the materials that you could have access to, including forest products, that be converted into this kind of material is of great interest to me. So I'm glad to see the research that we do, the research that you've done, making that kind of progress. If any of the other witnesses would like to or care to make a comment, feel free to do so at this time. I've got about 1 minute and 25 seconds left.
So this is Joe Hagerman with Oak Ridge National Lab, and partnerships are a key to our science, right? They're one of the fuels for our science. In our BTRIC user facility, we have 19 active CRADAs where we're actively working with companies, and companies seek us out. And DOE has just announced or has announced a technical collaboration program that companies can use and leverage Oak Ridge to solve their problems. And I think that's a wonderful way that we can augment U.S. companies and make them get to the results that we know they can have.
I think it's important, too, that our national labs, I'm very pleased that they're able to do some of the basic research sometimes that the industry cannot really justify, but that then leads into the kinds of things we're talking about here. So thank you very much. And I yield back.
Can I add as well?
Sure.
Yes. So I would like to add as well, coming from the background of being a general contractor before going into the national lab, really understanding that most general contractors are small and don't have the research budgets. And so the role of DOE and national lab being able to provide research and through programs such as Building America, where Building America is actually taking technologies that are developed in the lab and working with builders boots on the ground to actually deploy this, as well as retrofit contractors. And so that's just one example. Better Buildings is another. And then the ABC, Advanced Building Construction, is yet another initiative that is intended to do that, to be that venue where now we can develop science, take science, develop it into products, and bridge that gap for those contractors like myself back in the day to help get technologies developed that we can deploy.
Excellent point. Excellent point. I yield back. Thank you.
Ms. Bonamici is next.
Thank you, Chair Bowman and Ranking Member Weber. Thank you to all of our witnesses for joining us today and for your expertise. I know that residential and commercial buildings, we know this, are notoriously challenging to decarbonize. But to address the climate crisis, we need to meaningfully repair and rebuild our nation's infrastructure in a resilient and sustainable manner. So last year, I joined my colleagues on the Select Committee on the Climate Crisis. We released a bold, comprehensive science-based climate action plan to reach net zero emissions no later than mid-century and net negative thereafter. Our plan includes many policies to eliminate emissions from new buildings by 2030, increase homeowner incentives for energy efficient, affordable housing. And I look forward to working with my colleagues on this subcommittee and the full committee to advance these policies. Dr. Esram, I represent a district in Northwest Oregon. I know you're in the Pacific Northwest as well. In the district I represent, the Orchards, which was completed in June of 2015, at the time was the largest certified multifamily passive house building in North America. They anticipated in its 57 units to have a 90% energy reduction for heating and 60 to 70% overall savings in energy use compared to a typical building of its size. Not far from the Orchards is the headquarters of the First Tech Federal Credit Union, which is a 5-story, 156,000 square foot building built of cross-laminated timber. So in Northwest Oregon, the industrial sector is turning to mass timber as an alternative to steel and concrete. And cross-laminated timber, when harvested using sustainable forest management practices, can sequester and store massive amounts of carbon dioxide. There are still questions about the life cycle assessments of CLT, but the material raises the possibility of storing massive amounts of carbon in buildings for decades or perhaps in perpetuity. So Dr. Esram, in your testimony, you noted that the R&D gap in our understanding of life cycle carbon in build, that there is an R&D gap. So what initiatives could the Department of Energy's Building Technologies Office advance to better address embodied carbon and operational carbon emissions in building materials, equipment, and construction processes?
Well, thanks for the question, Congressman Woman. The most needed R&D gap is a standardized way to calculate the life cycle impact of all these materials, and also from a holistic perspective to consider building as an integrated entity, not just pieces, the concrete, the steels, the material level. I think we need to think about what is the target, how to standardize it, and also give innovation or freedom to the architect, to the builders, to create low embodied carbon buildings, and not just really at a surface level and go one step deeper, standardization, and the most holistic view of looking at embodied carbon in buildings.
And what difference would it make if we had those standards?
I think that will make the industry being more innovative to actively think about how can they create building products that include multiple benefits for the society and for the building owners and for the building occupants. Because currently our so-called life cycle analysis is too narrowly defined on the economic payback of a certain technologies or constructions. It's just
that's helpful. And I don't want to cut you off, but I really want to get a question in to Ms. Patterson. And Ms. Patterson, Portland State University recently released a study demonstrating how historically racist redlining housing policies in Northeast Portland have exacerbated the effects of warming temperatures and poor air quality. And for Black people and people of color. Extreme heat events are expected to increase in frequency and intensity because of the climate crisis. And as a result, these same historically underserved neighborhoods will face health risks of increasing temperatures, higher energy bills, and inequitable access to green spaces. And we know that many federal programs like the DOE's Weatherization Assistance Program can't meet current demand. So what does this mean for our BIPOC communities? And how can Congress better support innovative residential weatherization and energy practices, particularly for frontline households?
Thank you so much. Yes, I think one key strategy is to really think about spending priorities across the board and think about models that are multi-solving, so that we don't just think about energy retrofits that are just focused on energy retrofits through the Department of Energy, but we think about how we do energy retrofits that are tied to other, that are financed through health funding, because we know that having better indoor air quality and better temperature moderation and so forth are better for multiple reasons, and also tied to resources from Department of Labor. So we put together kind of cross-sector packages in order to be able to truly fund these and recognize that it's not just about providing one single thing, but it's about lifting the quality of housing and the quality of health and well-being, and think about how each of these sectors contribute to that goal. So I think really multi-solving is the key term there, and therefore multi-sector and multi-funding approaches.
Great, thank you. And I see my time has expired. I yield back. Thank you, Mr. Chairman.
Mr. Garcia is next.
Thank you, Mr. Chairman. Chair Bowman and Ranking Member Weber, thanks for pulling this together. This is actually very interesting discussions here. I want to thank all of our guests and actually congratulate you all for your achievements and your successes being leaders in your respective fields. I've got two questions. The first is for Dr. Tour, and the second is for Dr. Jackson. Dr. Tour, this graphene discussion is very interesting. When I saw the write-ups for this, I was doing some homework yesterday in preparation for today, and what I was looking at initially was whether or not the use of graphene would become a potential environmental risk, like what we've seen with PFAS creeping into our water tables. I'm sure you're familiar with what PFAS is, the polyfluoroalkyl substances. We have a contamination problem in California with PFAS getting into our waters, and while I was doing that research, I was reading that graphene is actually, it is effectively an allotrope of carbon, right? It's a derivative of sort of an activated carbon, and I was reading articles where graphene may actually be used to remove PFAS as a potential filtrate opportunity. Have you seen any research or done any research to where the use of graphene within water filtration systems can help mitigate our PFAS problems that we're seeing in some of our local communities?
Yeah, I don't know particularly with PFAS, but I know that graphene, these carbon materials, are indeed being used for water filtration. In fact, I have a company that's actually doing that, using graphene in water filtration systems, and the thing about graphene is it's already natural in a riverbed. It's shearing off slices of graphene. It's already naturally occurring, and that's what makes it all the more attractive, in that it's a naturally occurring material, hard to access, but for water filtration, the PFAS problem, there are other ways that we're addressing that, and actually my group is addressing particularly that problem. So I know something about that. And we've just recently gotten some grant money to do that through the Department of Defense to try to address specifically that PFAS problem.
If it's okay, I'd like for maybe you and I can take it offline, but I'd love to connect you with our local water districts here in my district in Southern California. They're struggling with this right now, as many are, but they're on the precipice of making very significant investments. And I'd rather make sure, I just want to ensure they're looking at all options before we go too far downrange. A lot of federal assistance going into this type of program as well, as you know. So I would love to be able to connect you offline if we can with some of our folks on our end.
Be glad to.
Thank you, sir. Dr. Jackson, so it's hard to believe, but solar power for residential applications has been around for 30 years now, maybe even a little bit longer. Can you talk to us a little bit about the generational shifts in solar power? I know the cost curve is coming down. It's Moore's law, really, right? It's double capacity, half price every 5 or 6 years. We're seeing that real time. Is it just an improvement in efficiencies and costs, or are there other sort of revolutionary increments in terms of the technology? I know the integration of solar into roof tiles now is a new thing, but can you talk to us about how the solar industry is actually, what is the state of the art, and why is that so important right now?
So I think that's a great question. I think we've seen some of the trends because of multiple things. I think it's a multifold. One being the materials. We have been able to go from some of the traditional semiconductor type materials that we used 30, 40 years ago, and now we're actually using even some organics, or even one of the things that's been really NREL has been leading on is perovskites. Is one of where you can basically paint it on. There's YouTube videos of painting on a PV device. And so one of the things, then the next step is, what do we do as we continue to advance the curve, is the saw cost, the cost of integration. Because if you make a super cheap material, but it takes a lot to integrate it, then the overall effective cost is still high. So that's been coming down as well. And then finally, where I see this going is now what we're seeing, it was a Nature Communications paper last year, where we took those advances in perovskites and other types of materials and said, what if you actually integrated those into your window, into your building facade? So now you can see that window that actually is glazing, you can see out of, but by innovating some technology that we have, you can make it where it switches, where it's a clear window when it's kind of the light isn't as clear, but then when the sun is readily available, it can actually serve as to help with glare while also collecting solar. So you have so it's taking that perovskite, those types of innovation, and incorporate into traditional facades and windows to be able to take solar innovation to the building envelope to the next level.
Oh, that's fantastic. Well, I can go on for hours on this stuff. Thanks, guys, for sharing very interesting technologies, and I yield back. I'm out of time. Thanks, guys.
Ms. Ross is next.
Thank you, Mr. Chairman, and thank you for having this be our first hearing. It's really fascinating. I want to talk a little bit about your initial theme for the hearing, and so which is, how do we get some of these technologies that are good for our environment and good for people's health in affordable housing? And right now in my district, I'm from the Research Triangle area. It's a growing area, and we are coming up against a real battle to get more affordable housing. At the same time, what used to be called housing projects are being torn down because they're past their useful lives, and the living conditions are not as good, and we're replacing them. And so I'd love to know from any of the panelists where there are good examples of sustainable, healthy, affordable housing projects in this country or in other countries, so that when we build again, we build in a way that all residents get the health benefits, get the energy efficiency benefits, and we get the environmental benefits. So to anybody, it looks like we have a few people who want to jump in. Yeah.
So this is Joe Hagerman with Oak Ridge. I can talk a little bit about our work with Clayton Homes. So Clayton Homes is the largest affordable housing manufacturer, I think, in the nation. We're working with them to apply some of the connected community principles into their manufactured housing and make those homes safer, more efficient, and healthier in terms of indoor air quality. And it's really about adding controls into their normal product and making those things world-class, and really taking the lessons learned from our previous projects in Alabama, Georgia, and with EPRI, the Electric Power Research Institute.
And as a follow-up, how can we in Congress create incentives to do that? So, some people who are in the affordable housing business are in it as a business. Other people are in it because they really care about the residents. Are there any triggers or incentives that we in Congress could provide to have these practices, best practices, be more widespread?
Oh, absolutely. So another project we have with the Knoxville Community Development Corporation, they're actually actively decarbonizing their buildings, and those are actually their words, right? And so I think we as a lab have really learned a lot from that in terms of seeing retrofits. And as you talk about best practices for retrofits, they need to pivot to see those as decarbonization events because it would make the house healthier for the homeowner, and they pay one less bill at the end of the day as well. So I think those incentives to really kind of rethink retrofits as a whole and incentives to help decarbonize or make the justification to decarbonize would help.
Thank you. Does anybody else know of examples around the country or around the world? Any of the other panelists?
I'll give an example. I think some challenges, because I think one of the things we have to be to ensure that we approach the affordable housing challenge, particularly with retrofits, those are distinctly harder. As the chairman mentioned, because in New York, I mean, we've seen in New York Times, we talked about like some of the urban heat island effects. And so a lot of times in projects, you see the actual temperature change, the temperature dynamics in those environments are different. So we have to think through them differently to make sure that we have the right solution for the right application. And so we've seen in Europe, some of the things they've done in Europe is to use modular construction and actually replace the whole building facade. And those are some of the things that the Advanced Building Construction Initiative through the DOE's funding, we're actually trying to say, how can we take the best from those things like in Energy Sprong that's done in Europe and say, what does that look like, or what is a modular type approach that could be used here, or a panelized approach and say, for these types of affordable construction, how do we do the best thing for that? Because just because it worked in a market rate or advanced market community doesn't mean it's going to work in an affordable community. And I think that's the challenge that we face, is if we do that, we end up with a less optimal or a less correct solution for those communities that actually need more investment. So to your question of what can we do, I think we need to have a very focused effort on the affordable community so that we can make sure we're developing the right solutions for those challenges.
Thank you, Mr. Chairman, and I yield back.
Mr. Feenstra is next.
Thank you, Mr. Chair and Ranking Member Lucas. Before I start, I just want to thank each of the witnesses for their testimony and sharing their extensive research and opinions with us. Iowa's 4th District, where I'm from, is no stranger to leading in energy and environmental design. With over 65 LEED certified buildings in my district, Northwest Iowa takes a sustainable buildings very seriously. Additionally, I'm an original co-sponsor on Ranking Member Lucas Solsta's Act that includes an increase in the investment in the DOE's Office of Science. Their research can help support the next generation of clean energy and efficiency and technology. Dr. Jackson and Dr. Hagerman, I got a question. Retrofitting existing buildings, which we have a lot of here in the 4th District, is one way to avoid the embodied carbon and cost produced from the building and construction process. What are some of the most cost-effective and carbon-reducing retrofitting techniques that can be utilized today?
So I'll start. I think the most cost-effective, one of the things is it's kind of, as an engineer, it depends. It depends on the application in many cases. And so for the climate, one of the things that you would do is the building facade to ensure that you get the biggest bang for your buck, because that helps you with resilience, particularly as we look forward with climate change and making sure that the building works today, but it also works 50 years from now. So the best you can do is a building facade. And so now going back to the question, or Dr. Esram mentioned before, we need to ensure that we understand the embodied impact of the materials that go into that facade. And so that's why we need to continue to advance the research in the embodied energy, so that as we do those facade retrofits that can be done today, they can use the least embodied energy approach. So that's one of the most readily available.
So this is Joe Hagerman from Oak Ridge, and I would answer controls and retuning. So controls. If you can get your controls right, tune up the equipment, you can save a lot of money. And then once we have controls available, we can make the schedules fit people's active lives. And then we can also expose those controls to the utilities so we can start using and leveraging those buildings as a resource to the grid to make the grid more resilient, just as we're making your house more resilient.
That's very good. Hey, this is for anybody. So my district, we're very high into agricultural production. And so we maximize the use of our bio-based materials. As an example, Iowa State Centers for Crop Utilization has worked on projects like creating adhesives and insulation from crops and crop byproducts. These can provide a cost-effective alternative instead of petroleum-based products. Is there a way, or how do we see that we can expand this research? Or do you think this is a good method that we should be spending our time on in future research?
So if I could answer that, yes, and right, we see a lot of those types of cellular materials going into the feedstock for our additive manufacturing machines. So I would encourage you to explore, other uses of those materials too, especially in the advanced construction kind of industry and this 3D printed world we're about to live in.
All right. Well, thank you so much, doctors. Mr. Chair, thank you, and I yield back.
Thank you very much. Before we bring the hearing to a close, I want to thank our witnesses for testifying before the committee today. The record will remain open for 2 weeks for additional statements from the members and for any additional questions the committee may ask of the witnesses. The witnesses are excused and the hearing is now brought to a close. We are adjourned.